Okay, so working with some trigonometry word problems and applications. And in this problem, we have an electric generator produces current described by this equation, right? Where I of t is amps, right? Where I of t amps is the current at t seconds, right? So, right, this I of t has units of amps or amperes, and it is a current flowing through this generator at some t seconds. So I want to state the amplitude, period, and phase shift for the sinusoid. Right? So we know that our amplitude is going to be given by that leading coefficient for our function, right? So we know that the amplitude is going to be the absolute value of 30, which is just 30. Okay, now my period. This is a sinusoid, so I know that my period is going to be my typical period, in this case 2 pi, divided by the coefficient of my variable, in this case 40 pi. So that would give me 1 over 20 as my period. And the units here, we're talking seconds, so this would be 1/20th of a second. Okay. Then we also have the phase shift for the sinusoid, and the phase shift, if I already have all of this factored out, my phase shift is simply going to be this value over here, right? So my phase shift is simply 7 over 12, right, units, and in this case seconds, to the right. Okay. Now with this information, I can draw my sketch. My period I know is 1/20th, so I have 1, 2, 3, 4, right? So I have 1/20th for my period. 1, 2, 3, 4. 2/20th, 1, 2, 3, 4, 3/20ths, right? So that's going to be my period. Now, my phase shift is 7/12 units to the right. Well, 7/12 is actually quite a large amount. 7/12 is actually quite a large amount. So I might, for graphing this, go ahead and use my calculator to help me out. And I'm going to say I have 30 sine 40 pi times my variable minus 7/12. All right, so I can use my calculator to help me have an idea as to what this graph's going to look like. Now my window, I can say I'm going to go from 0 to 3/20ths, right? And I'll say I have tick marks every 1/80th, because that's going to be 120 divided by 4. Okay, and I have that my amplitude is 30, so I'm going to make sure that I can see from negative 35 to positive 35, and I'll put those tick marks every 5 units. I'll go ahead and graph. And so I can see what my graph looks like. All right, and what it seems to be occurring, it seems to be that my maximum occurs just before my period, right? That my maximum seems to occur just before my period. So I'll come over here, I'll say that's positive 30, there's negative 30. So my maximum occurs just before my period. So I'm going to go ahead and come over here and draw in my maximums. Right, and those occur just before my periods, right? And my minimums, right? My minimums seem to be occur, right? Do occur, not seem to be. My minimums do occur halfway in between my maximums, right? So just a little bit before, halfway in between, just a little bit before, halfway in between, just a little bit before. Okay, and then at a quarter, I would have where I'm crossing near the x-axis, and if I look, I can see that I cross near the x-axis just before those quarter marks. Right, so just before that quarter mark, just before that quarter mark, all right, just before that quarter mark, just before that quarter mark, and I keep on following my pattern. All right, so now I can connect the dots with my graph. All right, it doesn't have to be beautiful, but it really shouldn't have these straight lines. They should be curved. And so I have a sketch of my graph, right? I have a sketch of my graph of I of t, all right? And t are my units. Now, I want to state to 2 decimal places the smallest positive value of t for which the current is 15 amps, all right? So what that's saying is that if I had my current of 15 amps, all right, so if I came across and I would say, okay, well, here is going to be 15 amps. I want to find out the smallest positive value where this happens, right? And so that smallest positive value is going to be right there at that intersection. So in order to find that on my calculator, I can come back to y equals, put it in the second graph at 15, graph it, and now find the point of intersection. So second, calculate intersection, arrow to my curve of 15. I'm going to arrow close to the point of intersection. Press enter once. Second curve, that's good enough. Press enter twice. Guess, press enter thrice, and it'll give me the estimation, right, to 2 decimal places. That's 0.00. So I'm going to go ahead and give it to 3 decimal places, which would be 0.004. Okay, so the time would be 0.004 seconds. And we've marked it clearly on the graph. So there are some light word application problems on working with the graph of the sine function and working with the graph of the cosine function and some respective phase shifts. Okay. Thank you very much for your time. I appreciate you.